So, welcome to DSA 441 Cloud Computing. Today, we are going to see about a relational database service, which is a product available with Alibaba Cloud. In the previous weeks, we have seen so many products like object storage service and then its demonstration. And we saw about the elastic compute service and its demonstrations, and then about auto scaling and server load balancer. So with these products, I have made a certification link from Alibaba Cloud that will be provided as a description to this video. So you can take all the videos including today's lecture, and then you can attempt for the questions which are given in that test, and that will fetch you a certificate from Alibaba Cloud, which is powered by Multi-Cloud for Your Technologies India. So for today, we are going to learn about the relational database service. So here in this video, we are going to cover the theoretical aspects of the relational database service. In short, we call this relational database service as RDS. So in the Alibaba Cloud portfolio, this RDS tool comes under the category of data intelligence, which has the pool of database. In that database, we have RDS for MySQL, RDS for SQL Server, RDS for PostgreSQL, RDS for PPAS, RDS for MariaDB, and then we have PolarDB for MySQL, PolarDB for PostgreSQL, and so many other tools are also available. In the next video, I will give a practical demonstration on this RDS. So in that, you will know how and what kind of tools are available and how you can utilize it. So when we go into this relational database service, we have a definition to know. It is a managed relational database service that is simple to deploy, easy to scale, reliable, and cost effective. In this scenario of RDS, what is the need for RDS? When we have a web application or a website which is connected to a kind of Apache server, and we can have like the PHP files running in, so we kind of control it using the kind of PHP files using the ECS instances. So these ECS instances will help you to distribute the traffic and make the service much more easier. But we need to have a database server also, like the database also has to be distributed, so it will be having like more or higher availability of data. For RDS to be able to easy to scale, we have a choice of database engines. MySQL is a database engine, MariaDB is a database engine, SQL Server is a database engine, and even PostgreSQL is also another database engine. And there are so many other database engines are also available with Alibaba Cloud. It gives a high availability because of the availability in multiple zones and multiple regions across the world. And then we have a high performance with respect to that. And when the performance is higher, management of service is easier, and it is easy to scale and operate. Like if we have like high traffic, then we can increase the number of RDS instances to manage the traffic coming into the database service. And we can even create as many number of RDS systems we need. So that's the benefit or usage of relational database service. RDS as a managed service, we have like a fully managed host as well as the operating system. As we see in ECS and OSS, they are all under the infrastructure as a service or IaaS, but this one comes under the platform as a service or PaaS. We will see about those things in the next few slides. So when we see about the host and operating system, there is no access to the database host operating system. We don't need to consider, or we don't need to care about what operating system is there in the database host. And there is a limited ability to modify the configuration that is managed on the host operating system. There is no function that rely on configuration from the host OS. We have a grab and go, which provides additional operation, monitoring and security tools. It guarantees up to 99.99% availability. How that availability can be achieved? If we use like a 3-node multi-zone deployment. Like if we have 3 nodes, each of them are located in different zones, then one zone gets cut off, the database can be retrieved from another zone, another node which is present in another zone. So that's how it increases the availability of relational database service, or RDS, and it provides automatic failover in case of primary instances which are not available. And for fully managed storage, it has a maximum storage limits. It can support up to 20,000 IOPS and 2 terabyte storage for each instance. It upgrades the instance memory and disk space according to our needs. So this RDS concept, we have the trade-off, the building database the traditional way. We need to firstly prepare the hardware. Firstly, we need to get a server, and then we need to install the operating system in that, and then in that operating system we need to install the database software, maybe MySQL or whatever it is, and then we have to configure, and after configuration we need to do the tweaking, that is to make the database available to the scope of the application. So this will normally take like a week to 10 days time, but if it is done in a very effective way, we can do it in 3 to 5 hours. So for making one traditional database, we need to spend this many hours, but when we use the RDS which is available in Alibaba Cloud, it just does the choose and pay, that's all. So you don't need to do anything, like you just configure certain things, you just choose what kind of database service you need, what kind of storage you need, and what kind of network system you need to connect to. All those you just click, and then it is configured, it is done. So this process of creating a cloud database using the Alibaba Cloud RDS will take less than 10 minutes of the time. So it will reduce the hardware requirement. Also it will reduce the time spent for getting this database. Now we are going to see about the relational database system service concepts which is present in the Apsara server. In Apsara server in data center, we have a Linux cluster. On top of that we have the various services like Futsi, Quafu, Zonkui and Nuva. And on top of that we have the distributed file system which we call as the Pango, and the job scheduling is Fusi. And this distributed file system of Pango houses the products like ECS, RDS and OSS. RDS is one among the services, and this will connect to the user through the APIs which we have. So this is the architecture on how RDS is placed in the Alibaba Cloud data center. Now in the earlier slide I mentioned that this RDS will come under the PaaS, that is the platform as a service. In previous infrastructure as a service, we saw about the ECS and OSS, that is the Elastic Compute Service and Object Storage Service. Those come under the infrastructure as a service, where we configure the networking, storage and servers and virtualization, all done automatically. We need to install only the operating system, middleware, runtime, data and applications. But in the case of platform as a service for RDS, we have until this runtime installed in the instance which we create. You don't need to even work on the operating system. You don't need to work on the runtime or middleware. The only thing we need is the data and the applications. We just need to configure that, and then it is automatically done. So that's how we have the platform as a service. We may ask, think like we are even configuring the software during the process. So why don't we say that as an SaaS? Because in SaaS we have everything done already. We don't need to configure. We don't need to choose anything. But here we are choosing the software. So that's why this RDS comes under the category of platform as a service. Now we see the difference between ECS and RDS. In the traditional system, we need to buy everything right from networking until the applications. Everything costs for us. But in the case of ECS, up to the level of virtualization, it is fully automated, and the user just need to worry about the operating systems until the applications. But in the case of RDS, until the case of runtime, everything is fully automated. Only the applications and data are managed. In the RDS concepts, we have a service architecture. So the RDS instances will have a control on high availability control system, and they have a backup system, and they have a system which migrates the online database, and it has a task scheduler system, and it has a monitoring system. All these are managed by using the RDS instances. These RDS instances are connected through a web API, or they are accessed through a firewall. So this firewall will increase the security of using the database. These RDS instances will have multiple databases. The databases are distributed, and they are made available in multiple nodes which are available in multiple zones and regions across the world. So that's how it increases the availability, and also usage of firewall will increase the security of the system. Now in RDS instances, it is a database service which is running on virtual computing environment. A user can decide certain parameters like the database engine, like what kind of database he needs, whether MySQL or a SQL Server or whatever it is. And then the CPU type, memory, storage, network capabilities, and the associated parameters of network of that particular RDS instance. So the user, when he or she creates the RDS instance, these are all the options given. So this is for customization. That doesn't mean that it has to be set up. It is automatically available in the cloud system. RDS provides a wide selection of instance types optimized to fit different use cases. The instance types comprise varying combinations of CPU, memory, storage, and network capacity. Now we have like different types of RDS instances. We have like 4 different editions. We have the basic edition, high availability edition, enterprise edition, and cluster edition. A basic edition, it has only one node which has one RDS instance. It has a very high cost effectiveness, but just for something like to know how the RDS works, we can go for this basic edition. But for maintaining an application, this is not highly recommended. It has a decoupled storage and compute and a single computing node. It has a very high cost effectiveness. And when it comes to high availability node, it has unlike the basic edition, it has 2 nodes. That is, one node will act like a master, and the other node will act like a slave. That is like a subordinate node. So this will increase the availability of the database instance. So this architecture, the node which acts as a master will do the computations, and then if in some cases, if the master node fails or it has some problem, then the slave node, that is a subordinate node, which which is in line, will take in charge and it will act as a master node. So then it will increase the availability of the data. It uses a solid state drive storage, which provides a better performance than the basic edition. And then we have enterprise edition. The enterprise edition has 3 nodes. That is, in 3 nodes it has one master node, just like the high availability edition. But unlike the high availability edition, in enterprise edition we have 2 slave nodes. We have one slave node in high availability, but there are 2 slave nodes in enterprise edition. This will guarantee a strong data consistency through synchronizing multiple log copies. That is, if the database transaction happens, the log of that particular transaction, or the log details, will be stored in multiple nodes. That increases the availability of the data, and financial level data readability and cross IDC disaster tolerance is available for enterprise edition. So these are the most commonly used editions in RDS for Alibaba Cloud. And then there is one cluster edition, which is right now, which is available only for SQL Server 2017 engines only, and it utilizes SQL Server functionality, which will provide a high availability. So that is the aspect of cluster edition. Right now, since it is available for SQL Server 2017 only, we are not discussing much about this particular edition. So in the basic edition, it contains only one node and it has no slave node for fault recovery. So here you see, this is the basic edition, and if the master database is gone, then there is no possible for fault recovery, and it has a lower cost, but the availability of data is lesser. In the high availability edition, 2 instances in the same or different zones with automatic data synchronization is available. So in case if the master goes down, the slave will take care. There will be a data center disaster tolerance by using the database duplication. This is how it increases the availability. The master and slave nodes in the high availability edition, if both the nodes are in the same zone, it will have a higher availability, and this availability will increase furthermore when these nodes are present in different zones. So this basic edition uses the storage computing isolated architecture and a single computing node, which realizes a super high cost effectiveness. The number of nodes is 1. This is normally used for micro websites for developing and testing the testing sites, like the testing of the products. So for those things we can use the basic edition, because if there is any fault, we can just we don't need to worry much. There is nothing lost with the productivity. But the high availability edition, it is done with the production database. So this is for the production database of large enterprises. So here we are concerned about the duplication of data to avoid the data loss. It uses a high availability architecture with one master node and another slave node. We have an ephemeral solid state disk storage, which provides the best and balanced performance. And when it comes to enterprise edition, we have 3 nodes. It uses a 3-node architecture with a master nodes and 2 slave nodes. This architecture guarantees a strong data consistency through synchronizing multiple log copies and provides financial level data. This data is reliable and has a cross IDC disaster tolerance. This kind of RDS instances are used for core databases with extremely high data security for financial securities, insurance, and other industries, like even for health record management, or many applications are available for this kind of aspects. And then we have like types of instances. We have a common instance as well as a dedicated instance or a dedicated host. In common instance, it is highly cost effective. The storage capacity is not linked with the CPU, and it has a flexible configuration. So here it is like we have each instance having a separate memory and separate input output, but all of them are sharing a same duplicated CPU storage space. So in the same CPU, it takes the different memory and different input output. That's about the instances. But in the case of dedicated instance, there is no sharing of CPU, but the remaining all are same. But the CPU is also like a dedicated. Like each dedicated instance will have its own dedicated memory, dedicated input output, CPU, and its reserved space. So all these are made dedicated for the dedicated instance. Whereas in common instance, we have the instances sharing the CPU. It has an automatic backup. We can configure a backup policy to adjust the timing of the RDS data backup and log backup. The automatic backup supports a physical backup also. So here in physical backup, we can also back up the RDS data at any time. Like we can use like a manual backup, and this manual backup can give physical backup as well as the logical backup. So in the backup systems, we can create the backup files. If your total backup is below 50% of the purchased instance storage space, there will be no extra charge, but the users can obtain temporary links to download their backup data as needed. The storage module also supports dumping backup files to OS's archive storage for more cost-effective offline storage. We can even download the backups which we have created in this system. And then we have some scenarios for data recovery. To restore the data of an Apsara DB RDS for MySQL database to its original instance or to a new instance, we can restore the data of an RDS MySQL instance, and then restoring the individual databases or tables for an RDS MySQL instance, and restore the data of an RDS MySQL instance across regions. Restoring the data of an Apsara DB RDS for MySQL database to a user's created database, we have to use a physical backup file to restore the data of an Apsara DB RDS MySQL instance to a user created database. Restore data from logical backup files of an Apsara DB RDS MySQL instance to an on-premise database. If the original data instance is not released, or you do not want to restore the data from a specific point of time, we can use a DTS to migrate the data from Apsara DB for MySQL database to a user created MySQL database. So here we can see the disaster recovery. When the instances are present in multiple zones, the availability will increase. Like we have all these are RDS instances. If the RDS instance is within the same zone, then that is one scenario, and the RDS instances are in multiple or different zones, it is a different scenario. So the first case, we have the RDS instance over here. So this is within the zone in region 1 zone A and region 1 zone B. So one instance is in zone A of region 1 and another instance is in the zone B of region 1. Whereas we have the region 1 in zone B, which is connected to the zone A of region 2. So we have like an inter-region replication of RDS instances. So the log which is connecting this particular system is more efficient. So for read-only instances, we have Apsara DB for MySQL, which allows the read-only instances to be directly attached to RDS in order to limit the read pressure on the master instance. The master instance and read-only instance have independent connection addresses. Also, we provide read-write splitting addresses to automatically balance the requests and perform read-write splitting. And then this RDS storage can be extended in several ways. We have memcache and Redis, and also we can use OSS. Memcache and Redis will provide a high response speed for cached hot data. The cache can support a higher QPS than the RDS alone. But in the case of OSS, it helps to reduce the storage pressure on RDS. So it can keep dumping the log data as much possible. So it keeps dumping and it will reduce the pressure on how to or what data has to be sent into OSS. And then we have this RDS monitoring. We can even call that as a cloud monitor. So this RDS console provides a full performance metrics, allowing the users to get a clear picture on the running status of each RDS database instance. The Alibaba Cloud Monitor metrics for RDS includes the CPU utilization, how many percentage of the CPU is being utilized, and the storage, that is the storage space occupied, and the memory accessed during the transactions, and many other aspects are available like IOPS usage, connections usage, MySQL network outflow, inflow, and then for many other metrics are also available in this RDS cloud monitor. RDS actually provides security also. It gives a 3-level security defense system to protect databases against the security threats. The most important threat is the anti-DDoS. It provides a real-time traffic monitoring at network entry point. If any high traffic attack is identified, the traffic from source IPs is either filtered or blacklisted. Thereby we can stop accepting the requests from the malicious nodes which are giving like denial of service attacks. And then we have a whitelist configuration, that is we can support up to 1000 IP addresses. So we can make sure that the request from only certain number of IP addresses can be allowed to access. Others can be sent into a blacklist. Those IPs in the blacklist cannot access this RDS instances. And then the next attack is about the WAF, that is the web application firewall, which intercepts the SQL injection, brute force attacks, and any other types of attacks corresponding to the databases. Apsara DB for RDS also provides SQL audits, allowing you to keep track on who, what, and when of DB access and modifications. So these are the major types of security threats handled by the relational data service of Alibaba Cloud. And then we have this RDS security for RAM, that is the resource access management users. In the traditional systems, we have the applications and the users, and then the database administrators controlling the database. But in the case of RDS, the RDS is controlled by the RAM than the users, and then they have like operations and database administrators. So there is a reduction in the number of control, but it is made even more efficient than the traditional ones. And now we see about the new authorization management system. We have the operator, developer, tester, auditor, and intern. They all go into one particular system. Based on their type of user, there will be some permission types given, whether to give only for query, only for update, or can be given all the permissions, and then the time of giving the permissions. For example, the intern can be given like 30 days of access or 7 days of access, and the remaining people can be given like 365 days of access. And then the target will be like whether it is about the database schema or on only for certain columns, and avoiding send some sensitive columns to certain users, or to give access to a table or not. And then this DMS unified authorization management system will have an account revoke or column granularity, individual account, or overdue notifications. Based on this, the access is given and the control is made. So for the RDS security access control, it will require the IP address ranges to be whitelisted before the clients running in them can access any database. This includes the external clients and ECS clients in the same EPC. The RDS allows the setting up of SSL connections from ECS to RDS via load balancers. We have seen enough about the server load balancers in a previous video. This will allow the clients to perform an end-to-end encryption to the connection. So the picture which is listed here will show how this access control has been done. So this ECS instances through the SLB will connect through the primary or master databases. And about the demonstration, it will be in the next video, and in the next week we will learn about the cloud security. So I hope all of you understand this. The slides for this presentation will be given in the description of this video. Thank you.